Welcome to our deep dive on bird communication. Get ready to rethink everything you thought you knew about bird songs. We're about to uncover a world of avian intelligence that's, well, it's far more complex than just, those simple tweets we hear.
You've got that right. We'll be exploring how birds use alarm calls, and these aren't just like basic warnings. They're more like a whole sophisticated language packed with information about predators and the dangers they represent.
And you sent over some incredible excerpts from Bird Sense by Tim Burkhead, right?
That's right.
It's fascinating. The book delves into how birds perceive the world around them, and I'll admit, I'm already hooked. Let's start with what appears to be a tranquil setting, the Australian National Botanic Gardens. What makes it such a compelling location to study, how birds communicate?
Well, on the surface, it seems like an avian paradise. You see all these vibrant birds just fluttering about, but beneath that beauty, there's a whole kind of underlying network of predator-prey dynamics. It creates, a high-stakes world for these birds.
It's like a beautiful stage, but for a nature documentary, but with real-life drama constantly playing out.
Exactly. The source mentions everything from like venomous snakes and those sneaky cuckoos to even introduced predators like feral cats and foxes. Survival is a constant challenge out there.
And of course, there are the avian predators themselves. You've got your kookaburras, currawongs, and then the notorious collared sparrowhawk. Can you imagine being a tiny bird and constantly having to watch out for these, aerial assassins?
Yeah, the collared sparrowhawk, they're particularly skilled hunters. Known for their speed and agility, they pose a serious threat to smaller birds.
It's no surprise, then, that these birds have, developed such sophisticated ways to communicate about danger. Now, you mentioned a star informant, the New Holland honeyeater. What's so special about this particular bird?
The New Holland honeyeater, it's this small black and white bird with a surprisingly powerful voice. And get this, their alarm calls, they're incredibly complex. We're talking up to 96 different elements in a single call.
Wait, 96 elements? In one call? That's more than some human languages have. I mean, what kind of information could they possibly be squeezing into those calls?
That's the question. Jessica McLaughlin, a researcher at Australian National University, is trying to unravel. She's had to get really creative with her research methods, like using hidden cameras and microphones to capture, the bird's subtle reactions.
It sounds like she's become a master of avian espionage. I can picture her camouflaged in the trees, trying to blend in.
Well, she has mentioned, being mistaken for part of the exhibit a couple of times.
Okay, so they have this vast vocabulary of alarm calls.
Yeah.
But how do they actually use them? I mean, are there different calls for different situations?
Absolutely. You've got your mobbing calls and your flee alarm calls. You've probably heard both without realizing it.
You know what? Now that you mention it, I think I have. When I see a crow, eyeing the cardinal nest outside my window, all the birds in the neighborhood just go crazy. It's like they're all yelling at the crow to back off.
That's a perfect example of mobbing calls. They're used for threats that aren't immediate, like rallying other birds to basically harass the predator. A classic strength in numbers strategy.
It's like a neighborhood watch, but for birds. Everyone teams up to protect each other.
Right. And then you have your flee alarm calls. Those are the high-pitched, urgent ones that send every bird diving for cover. They signal immediate danger, usually from an aerial predator.
Like they're shouting, "Incoming, hit the deck!" And poof, they're gone.
Exactly. Those calls are designed to be hard to locate so the predator can't, pinpoint where the bird is.
It's incredible how they've developed these distinct calls for different situations.
Yeah.
But are they just reacting instinctively, or is there something more going on here?
That's where things get really interesting. For a long time, scientists believed that the ability to, refer to specific things, different types of predators, was unique to humans. But research has shown that this referential signaling, as it's called, exists in the animal kingdom, too.
So you're saying that birds might actually be communicating specific details about a threat, not just a general sense of danger.
Precisely. And it goes beyond simply identifying the type of predator. Birds can also communicate about what the predator is doing.
Hold on, so they're not just saying hawk. They're saying something like hawk is hunting, or even hawk is about to attack. That's next level communication.
Exactly. Siberian jays, for example, they have different calls for a goshawk that say perched or searching or actively attacking. They're literally signaling the predator's behavior.
So the information packed into these calls is incredibly detailed. It's like they have a whole playbook for responding to different threats.
And the level of detail doesn't stop there. Some birds can even use the number of notes in their calls to like indicate how far away a predator is or how dangerous it is.
Wait, so the more notes, the closer or more dangerous the predator? Seriously.
Think of the black-capped chickadee and its chickadee call. The more Ds at the end, the smaller and more dangerous the predator is. A big owl that's not much of a threat might only get a few Ds, but a speedy little falcon could trigger a whole string of them.
So even seemingly simple bird songs can encode this complex information about the type and severity of threats. That's amazing. It makes me wonder if there's even more to these calls than we realize. Wow.
Absolutely. And that leads us to a fascinating puzzle that researchers are trying to solve. How do birds balance the need to communicate this detailed information with the need to react quickly, in a life or death situation?
Yeah, because wouldn't all those extra notes in a call, wouldn't that take up valuable time? Wouldn't it be better to just have, like, one short, sharp alarm and get out of there?
Right. That's the dilemma Jessica McLaughlin's been looking at with those New Holland honeyeaters. Remember, their flea calls can have, up to 96 elements, so it seems like a lot to process in such a short time. But then again, maybe those extra elements are what makes the difference between life and death.
So how do they manage to get all that information across when every second counts? Balance the need for urgency with all those details.
Well, McLaughlin's research suggests it's the first element of the call that's key. Like it acts as a general danger signal, triggering that immediate flea response.
Ah, I see.
Think of it like a fire alarm. You don't stop to figure out where the fire is, you just get out.
That makes sense. So the first element is all about getting out of Dodge fast. But what about all those other elements? What are they for?
That's where things get even more intriguing. McLaughlin believes those remaining notes might provide more specific information about the situation, like maybe how long to stay hidden or the best escape route. It's like the fire alarm not only telling you to evacuate, but also, which exit to use.
So it's a two-part system, danger run, followed by, okay, here's the plan. That's incredible. It really shows how intelligent these birds are.
It really does challenge our assumptions about what those tiny brains can do. And here's another thought. Do other species understand these complex alarm calls?
That's a great question. It would make sense for birds to be able to eavesdrop on each other's warnings, especially if they share the same predators.
Exactly. And there's evidence that they do. For example, superb fairy wrens, they understand the alarm calls of white-browed scrub wrens and Australian magpies. They've been shown to decode the different alarms of noisy miners. It's like they're all part of this big intelligence network sharing crucial information about threats.
It's like a neighborhood watch, but on a much grander scale, spanning multiple species. That's fascinating. So are you saying all birds just instinctively know what each other's alarm calls mean?
Well, that's what scientists used to think. But Rob McGrath's research suggests that learning plays a much bigger role than we initially thought.
Oh, really? So it's not like they're born understanding all these different calls.
Right. Remember how McGrath found that fairy wrens in different locations respond differently to noisy miner alarm calls? Well, that suggests that they're not born knowing those calls. They're learning them through experience.
So it's like they're picking up on the local dialect of danger signals. That's amazing. But it also raises another question. How do young birds learn which calls mean danger in the first place? It seems a bit risky to just wait around and see what happens, right?
That's a good point, and it's something researchers are still trying to figure out completely. It seems like there's probably a combination of instinct and learning going on. Young birds might have an innate fear response to certain sounds, especially those high-pitched flea calls. But the specific details, the nuances that help them distinguish one predator from another, those are most likely learned through observation and experience.
So it's like they start with a basic foundation of fear responses.
Yeah.
And then build on that by watching what the older, more experienced birds are doing. It's like an apprenticeship in predator recognition.
Exactly. And those mobbing calls we talked about earlier, they might actually play a role in this learning process too.
You mean like a training ground for recognizing threats?
Kind of. When older birds mob a predator, the younger birds can watch the predator hear the alarm calls and see how the whole group reacts. It's a very effective way for them to learn about the dangers in their environment.
It's like this immersive learning experience, right? See the threat, hear the alarm, feel the energy of the group. It's got to be much more effective than just looking at a picture in a bird book. But here's something I've always wondered about. Why would birds even bother mobbing a predator? It seems incredibly risky, especially for those small birds.
That's a really good question, and it highlights how complex the balance of costs and benefits is in the animal world. Mobbing might seem counterintuitive, but there are actually several potential benefits that could outweigh the risks.
Okay, I'm all ears. What are the benefits?
Well, first off, it can actually be successful in driving a predator away. If enough birds are harassing and dive bombing it, the predator might just decide it's not worth the effort and move on.
Like they're saying, hey, we see you and we're not going to make this easy for you.
Exactly. And it's not just about immediate defense either. Mobbing can also have a long-term deterrent effect. If a predator keeps getting harassed in a specific area, it might learn to avoid that spot in the future.
Like establishing a no-fly zone for predators. This neighborhood doesn't tolerate troublemakers.
Precisely. And remember that teacher benefit we mentioned before. Mobbing provides a valuable learning experience for younger birds. They get to witness the adults' reactions and learn how to identify and respond to threats. It's like passing on essential survival knowledge to the next generation.
It's amazing how much is happening beneath the surface of what seems like a simple behavior. It's not just about defense, it's about education and protecting their community.
Exactly. And alarm calls aren't the only way birds communicate. There's a whole other world of communication happening in their songs too.
You're right. I've always loved listening to birdsong, but I've never really thought about what it might mean beyond just a beautiful melody. What else is going on there?
Well, it turns out birdsong is incredibly complex, and it serves a whole range of purposes, from attracting mates to defending territory to even recognizing individuals.
So it's like their own version of language with different songs for different situations.
In a way, yes. And some birds have repertoires of dozens, even hundreds of different songs.
Wow, that's incredible. I'm starting to realize how much we don't know about bird communication.
And speaking of complex communication, there's a fascinating connection to human whistled languages that are used around the world.
You mean like the whistled Spanish they use in the Canary Islands?
Yeah.
I remember learning about that. It's amazing how people have adapted whistling to communicate complex information over long distances.
Exactly. These whistled languages are used in places where it's tough to communicate verbally, like mountainous regions or dense forests. They're incredibly efficient, too. They can cut through noise travel over long distances and even convey subtle shades of meaning.
It's like they've taken the efficiency of bird calls and adapted it for human communication. That's pretty ingenious, don't you think?
It really is. What's fascinating is that these whistled languages aren't just simple codes. They actually mirror the intonation and rhythm of spoken language. It's like they've translated the language into a different form.
Makes you wonder if maybe we've underestimated the complexity of bird communication, too. If humans can pack so much information into whistles, just imagine what birds with their superior hearing might be capable of.
It's a humbling thought, isn't it? We might be missing out on a whole world of conversations simply because we don't speak the language.
Like we're listening to a radio station, but we can only pick up part of the frequency. We're getting bits and pieces, but missing the full richness of the message.
And even with our limited understanding, the research we've discussed paints a pretty remarkable picture of avian intelligence. These birds aren't just reacting instinctively, they're processing information, making decisions, and communicating with a level of complexity that rivals some forms of human language.
It really makes you realize that intelligence isn't limited to humans, and that the natural world is full of wonders that we're only just beginning to grasp.
So the next time you're out in nature, take a moment to really listen to what's going on around you. Those bird songs and calls might be carrying more information than you think. They might be telling stories of danger survival and even complex thought.
The whole world of communication waiting to be discovered. And who knows what other secrets are hidden in the sounds around us. It's interesting to think about how we've defined intelligence for so long. Like we've created this exclusive club and left out all these incredible species that are obviously capable of complex thought and communication.
It's true. We've often used language as this barrier between humans and the rest of the animal world. But the more we learn about animal communication, the more that distinction seems kind of arbitrary. Like we're realizing that intelligence is more like a spectrum with so many different ways of expressing it.
Right. And this research on bird alarm calls is just one example. Scientists are discovering language-like abilities in all kinds of animals, from primates and dolphins to even insects.
It's really exciting to see all this new research. It's like we're finally starting to tune in to this symphony of communication happening all around us, and it's way more intricate and multifaceted than we ever imagined.
Okay, so we've covered a lot of fascinating stuff, but I'm curious, why should we care about all of this? I mean, why should we be interested in the complexities of bird alarm calls? It might seem like a niche topic, but I have a feeling there's something bigger here.
You're absolutely right. Understanding animal communication isn't just about satisfying our scientific curiosity. It has some pretty significant implications for understanding the natural world and our place in it.
So how does it connect to the bigger picture?
Well, for one thing, it emphasizes the importance of conservation. These birds, with their intricate communication systems and impressive cognitive abilities, are crucial components of their ecosystems.
So it's not just about saving birds for their own sake. It's about preserving the delicate balance of the whole ecosystem.
Exactly. Losing these species would be devastating, not only for biodiversity, but for our understanding of the natural world. It would be like losing a library full of knowledge that we've barely even begun to explore.
And it goes beyond protecting nature for its own sake. Understanding animal communication can actually benefit us directly. Researchers are studying bird alarm calls to develop new ways of detecting and managing pests in agriculture, for example.
That's a great example of biomimicry. Taking inspiration from nature's solutions to solve human problems. It really highlights the potential for collaboration across different scientific fields.
It's like we're realizing that nature is full of these amazing engineers and inventors. We just need to pay attention and learn from them.
And maybe the most important takeaway from all of this is a sense of wonder and humility. These birds with their tiny brains and what might seem like simple calls are capable of so much more than we ever thought possible.
It's a good reminder that we're not the only intelligent beings on this planet and that we have a lot to learn from our fellow creatures.
So next time you're out in nature, take a moment to really listen. Those bird songs and calls might be conveying more information than you think. They might be sharing stories of danger survival and even complex thought.
It's an entire world of communication just waiting to be discovered. And who knows what other mysteries are hidden in the soundscapes around us. It's an exciting time to be a bird watcher, and even more exciting time to be a scientist exploring the lives of these incredible creatures.
Absolutely. There's so much more to learn and uncover, and it's a journey that's sure to be filled with surprises and new insights.
Well, that's all the time we have for this deep dive. Thanks for joining us.
Yeah.
I know I'm definitely going to be listening to bird songs with a whole new level of appreciation.
Me too. It's amazing what you can discover when you start paying